Howdy, partners. I'm helping your teacher, Mr. Bush, with some math problems. So I hope you enjoy them. Some of them are hard. Watch out. Yeah. Okay. 2017 number 1, I think. So when they give you a table of values, remember the trick is to graph it. So when height is 0, the area is 50.3. When the height is 2, it's 14.4. 5, and you can sell it. It's 2 wide, that's 3 wide, it's always this way. And 5 wide. 5 is 6.5 and 2.9. Not to scale, but just as it's decreasing. And for A, we want, let's read this. A tank has a height of 10 feet. The area of the horizontal cross section of the tank when the height is H is given by A of T. And here's a table with A of T and H, where A of T is measured in square feet. Okay, the function A of T is a continuous function and decreasing as H increases. And you can see with those numbers that makes sense. In the table, selected values are given. Okay. So use a left Riemann sum. So here's the first subinterval. The left side is this. So left Riemann sum, the first interval looks like that. The second one like that. So it's weird because the left Riemann sum, you are drawing your lines to the right. Right? In a right Riemann sum, you draw your lines to the left. But it's left because you use the left number in each subinterval to determine the height of each one. So this is 2 times 50.3. This is 3 times 14.4. This is 5 times 6.5. And we find the areas of those 3 rectangles, and that will give us, find the approximate volume of the tank. So volume is approximately, or integral from 0 to 10 of A of H d H is approximately one of those two, right? And then it's 2 times 50.3 plus 3 times 14.4 plus 5 times 6.5, and we can find this number. One 76.3. And indicate units. So this is a volume. It's feet, cubic feet. Okay. So B, is this an over or an underestimation? And you can see that's an overestimation. Because the function is decreasing and we used left Riemann sums. Use a left Riemann sum. Okay. C, the area in square feet of the horizontal cross section at H, interesting, is modeled by this function. So maybe when we plug these H values in, we get essentially these Y values. Oh, I think that's probably true. Wait, so anyway, C. Based on this model, find the volume of the tank. So we want a volume is the integral from 0 to 10 of f of h dh. And that is ooh, look at this. I already have it in there. I must have done it recently. So we want to integrate from 0 to 10 y1 dx. And you get 101.3253. And of course, that is an overestimation, right? Cubic feet. And D, water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at a rate of 0.26. So this is dH dt. The height is increasing. Okay, using the model for part C, this is the volume, and we integrate it based on the height. Find the rate at which the volume is increasing. So we're looking for dV dt when the height is 5. So we know h is 5, we know dH dt, dV dt. The only issue, this is h. If we integrated this in terms of time, right? We took this thing, actually, if v is the integral from 0 to h, f of x dx, or any other variable, f of w, dw, whatever, let's integrate this in terms of time. Integral of this in terms of time is dV dt. Integral of this in terms of time is f of h. It's the integrand with this h plugged in, but then we have that variable h, so we have to multiply it by dH dt. Okay? I think we know all this, right? F of h, f of 5, f of 5 is, well, here's f, so we just go to the table and plug 5 in, and it's, I like to have more decimals, 6.5169945. 6.5199945. Okay, so at h equals 5, dV dt is 6.5199945 times 0.26. And that's 1.652. 1.6952. And that would give you the wrong answer. Let's see, what did I do? at 6.51699. All right, that'll change things. Oh, darn, I would have gotten that one wrong. There it is. 1.6944. 1.6944. 1.6944. This is rate of the change of the volume. So it's cubic feet per, I need a time unit, minute. Okay. All right. Hopefully that makes sense to you. We could check out the scoring guidelines. The first part, we need, the first point is correct units. So we need cubic feet, and cubic feet per minute. And I think we're good. Second one is left Riemann sum and approximation. So I think we did that fine. Third part is an overestimation or under. Left Riemann sum that's decreasing is an overestimation. So that's good. The next one, we just had to integrate f of h dh and got 103. And that's correct. And the last one, oh, I didn't quite do it the way they did. There's the model, right? That's the same. Oh, I skipped this thing. I did that. dv dt, I think I like what I did really well. All right, dv dt is the integrand. It's the integrand. The integrand times the rate of change of that variable in terms of time. And then you plug in the numbers and get the answer. So there you have it. I think we got all the points.